Hi dear students, in this video we are going to discuss the previous year questions from class 10 science chapter chemical reactions and equations. So as we move on to this session, we will be going through the questions and also the in-depth theory to answer those questions. So let's move on to question number 1. The first question is, balance the following chemical equation. As you all know, in the chapter chemical equations and reactions, we learned that every chemical reaction, when it takes place or when every chemical change happens, the law of conservation of mass is always satisfied, which means before the reaction, whatever number of atoms or elements are present, those many elements or atoms should be present after the reaction as well. Basically, chemical reaction is just a rearrangement of the atoms. So the condition for writing a chemical equation is that the total number of atoms before the reaction has to be there after the reaction as well. So law of conservation of mass, it says the total amount of reactants must be equal to the total mass of the products. So if you look into this equation which is given here, Fe plus H2O giving Fe3O4 plus H2, we can see that this equation does not satisfy the law of conservation of mass, because on the left hand side the number of iron atoms present is 1. But on the right hand side, you can see that in this formula, there are 3 atoms of iron. Again, the number of atoms on left hand side, hydrogen is 2, the right hand side is also 2. So hydrogen atoms are balanced. The number of atoms of oxygen on the left hand side is 1, whereas the right hand side is 4. So in order to balance this equation, we need to look at what is the total number of atoms in each case which are unbalanced. So if I put the number of atoms of iron as 3 on the left hand side, I have balanced the atoms of iron on both sides. But we have 4 atoms of oxygen on the right side, but only 1 atom of oxygen on the left side. So I am going to multiply 4 in front of water, which makes the number of atoms of oxygen 4. So oxygen atoms are also balanced. Next we have total 8 hydrogen atoms on the left hand side, but only 2 hydrogen atoms on the right hand side. So when I multiply 4 in front of hydrogen, it becomes 8. So now you can see that the total number of atoms on the left sides are 3 iron atoms, 8 hydrogen atoms, and 4 oxygen atoms. Whereas on the right hand side also, we have 3 iron atoms and 4 oxygen atoms and 8 hydrogen atoms. Now we can say this equation is balanced. I hope you understood the idea of law of conservation of mass and balancing the chemical equation. So let's move on to the next question. Again, a question related to balancing. So as I said, we have to count the number of atoms on both the sides of the equation and make them equal. So in this reaction, we have lead nitrate undergoing decomposition. So lead nitrate is PbNO3 twice, and it is decomposing into lead oxide, nitrogen dioxide, and oxygen. So let's make a count of each atom present. On the left hand side, you can see there is 1 atom of lead. Then we have 2 atoms of nitrogen. Then we have 6 atoms of oxygen. On the right hand side, I have 1 atom of lead, 1 atom of nitrogen, and 1 plus 2, 3 plus 2, 5 atoms of oxygen. So here, the number of atoms of lead are equal on both sides, but nitrogen and oxygen are not equal. So, let's try to balance nitrogen. So, in order to balance nitrogen, let me multiply here with 2 so that the number of nitrogen atoms on both sides are now equal. Now, let's make a count on oxygen because that's the only atom which is not balanced now. So, we have 3 times 2 here, 6 oxygen atoms. And this side I have 1 plus 4, which is 5, plus 2, 7 oxygen atom. So the number of oxygen atom is the only one which is not balanced. So here what I'm going to do is, I can see that the number of oxygen in this side is 6 and this side is 7. So the right side has 1 excess oxygen. So what I'm going to do is, let me make this as half O2. You know, while balancing, we can use fractions, but in the final balanced equation, you are not supposed to have fractions. So the number of atoms of oxygen is now 6 here, and here also it is 6. But you know, I want to get rid of this fraction. So what I'm going to do is, I will multiply this whole equation with 2, which makes it as 2 PbNO3 twice, giving 2 PbO plus 4 NO2 plus O2. Now I can see that there are no fractions remaining and the equation is well balanced. And every time when you finish balancing, please cross-check and see that the number of atoms of all the species are equal. So let's do a check here. Here we have 2 atoms of lead, 4 atoms of nitrogen, and 12 atoms of oxygen. Here we have 2 atoms of lead, 4 atoms of nitrogen, and 2 oxygen here, plus 8 oxygen here, which is 10, plus 2 oxygen here, that is 12 oxygen. Hence, both the sides have same number of atoms. So I hope with these 2 questions, you're clear with the idea of law of conservation of mass and also how to balance the chemical equation. Let's move on to the next question. Name a reducing agent that may be used to obtain manganese from manganese dioxide. See, there are so many choices of reducing agents that you can use. And if you remember, one such reducing agent that you have studied in the chapter metals and non-metals, when you were studying about the thermate reactions, aluminium can be used as a good reducing agent. For example, if I have manganese dioxide and I add aluminium into it, it will result in the formation of Mn plus Al2O3. And this is a highly exothermic reaction and it liberates a large amount of heat such that the metal formed is in the molten state. Such a reaction which emits a large amount of heat is called as thermate reactions. And you have studied this in the chapter metals and non-metals. And this reaction is also an example for a redox reactions. Why? Because we can see that MnO2 is finally changing into Mn. And during this course of reaction, MnO2 is losing oxygen. And losing oxygen is called as reduction. And if you look into aluminium, aluminium is changing into aluminium oxide, which is the process of gaining oxygen. And you have studied that the process of gaining oxygen is called as oxidation. Hence, in a reaction, when one species is getting oxidized, the other species will definitely be getting reduced, and such reactions are called redox reactions. And one more point I would like to add here is, during the process of reduction of MnO2 into Mn, I told you that oxygen is lost by MnO2. And that oxygen is gained by aluminium. So we can say that, in a way, Aluminium is responsible for reduction of MnO2. So any agent that helps in reduction is called as a reducing agent. So in this reaction, the reducing agent is aluminium. Now, in a different perspective, if you look into what happens to aluminium, we say that aluminium is becoming aluminium oxide. During the course of this reaction, oxygen is being added. So where is that oxygen coming from? It is coming from MnO2. So in a way, we can say that MnO2 is responsible for oxidation of aluminium, right? So we call such agents as oxidizing agents. Oxidizing agents. So I believe with this single question, we learned a lot of things. We learned about what is a thermit reaction. We learned what is redox reaction. We learned what is reduction, what is oxidation, what is reducing agent, what is oxidizing agent. So this is the way how you should practice. When you do questions, try to recollect all the information or the relevant theory that you have learned about the same. Okay, so let's move on to next question. What change in the color of iron nails and copper sulfate solution you observe after keeping the iron nails dipped in copper sulfate solution for about 30 minutes? So here, the conditions of the reaction. We have iron nails and copper sulfate solution reaction. So when an iron nail is dipped in copper sulfate, you know that in the electrochemical series, iron is located above copper, which means iron is able to displace copper from the salt solutions of copper. Hence, we can say the reaction proceeds like this and it results in the formation of ferrous sulfate and copper. This is an example for a single displacement reaction. And in this reaction, iron is displacing copper from copper sulfate. And what are the observations that we see during this reaction? In this reaction, definitely we will observe a color change. You know that aqueous copper sulfate is having a blue color, whereas ferrous sulfate solution is green in color. So the immediate observation after the reaction is completed is the color change of the solution from blue to pale green. And moreover, if you dip the iron nail in the copper sulfate solution, the rest of the iron nail which is left unreacted will have copper deposited on top of it. And copper is a reddish brown metal. So the appearance of brown coating on the surface of iron nail is due to the deposition of the copper which is displaced from copper sulfate. So this is the observation that happens or that is observed during this particular chemical reaction. I hope this reaction is also clear to everyone. So let's move on to the next question. In a double displacement reaction, such as the reaction between sodium sulfate solution and barium chloride solution, they have given certain observations here, and the question is, the correct option is. So let's try to visualize that reaction. We are mixing sodium sulfate and barium chloride. You guys know that sodium sulfate is Na2SO4 and it is a solution. So an aqueous solution of sodium sulfate is mixed with barium chloride solution. Again, barium chloride is also in the form of solution, so it's an aqueous solution. It is going to undergo a double displacement reaction. You guys know that double displacement reaction happens when there is a mutual exchange of ions taking place, correct? What is mutual exchange of ions means? In sodium sulfate, you guys know that there is Na plus ions and sulfate ions. And in barium chloride, we have barium ions and chloride ions. So double displacement happens when the ions undergo exchange So sodium will be exchanging with chloride and barium will be exchanging with sulfate. And the products that we are going to see is barium sulfate and sodium chloride. So if you write the balanced equation, it will be BaSO4 plus 2 NaCl, as there are two atoms of sodium and chloride on the left hand side. Now, barium sulfate is a salt which is insoluble in water. So definitely that salt is going to precipitate at the bottom of the test tube. And NaCl is soluble in water, so it will be in the solution itself in form of aqueous. So this is the overall reaction, and let's read what are the points given here. The first thing says exchange of atoms takes place. It's not, because we don't see any exchange of atoms. Rather, we see exchange of ions. So we can say exchange of ions takes place is a correct option, but exchange of atoms doesn't happen. A precipitate is produced. Of course, barium sulfate is insoluble in water, so definitely it will precipitate at the bottom. Then an insoluble salt is produced. That is again true, because barium sulfate is insoluble in water, so it results in the formation of that precipitate which is white in color, which is barium sulfate. So out of all the four options A, B, C, D, we can see B, C and D are correct. Therefore, the correct option of this question is option D. So this double displacement related question is a very frequently asked question. You can see this question is asked in 2020. If you go into the next question, you can see in 2021, a similar related concept based question is asked. Look at this question. A student took sodium sulfate solution in a test tube and added barium chloride solution into it. He observed that an insoluble substance has formed. The color and molecular formula of the insoluble substance is. See, in 2020, they asked the same reaction with a different mode, and now in 2021, they have asked the same question in a different pattern. So that reaction between sodium sulfate and barium chloride is very, very important. So here the precipitate formed is barium sulfate, and I already told you that it is colorless or it is white in appearance. So the correct option here will be option C. So I hope everyone understood this clearly. So please keep in mind about double displacement reaction and this specific example of barium sulfate formation. Right, guys? So let's move on to the next question. Sodium reacts with water to form sodium hydroxide and hydrogen gas. The balanced equation which represents the above reaction is. See, when they ask you to identify the correct balanced equation, first you read the word equation given in the question. Sodium reacts with water. You know that sodium is an element and it is a metal and it exists in solid state. And water is a liquid and it results in formation of sodium hydroxide. Sodium hydroxide is a base. It is basically an alkali and it is very much soluble in water, so it will be staying in water in aqueous format. And hydrogen gas is H2. So it is a diatomic gas and it exists in the gaseous state, right? So the balanced chemical equation represented. So we can write sodium in the solid state is going to react with water in the liquid state, giving sodium hydroxide, that is again in the aqueous state, plus hydrogen in the gaseous state. This is the balance, this is the skeletal equation of the reaction. Now we have to check whether it is satisfying the law of conservation of mass or not. If not, you have to add the necessary stoichiometric coefficients to balance it, right? So let's make a count. Sodium atom on the left side is 1, here also it's 1. Hydrogen we have 2 here, here we have 1 plus 2, total 3. Oxygen we have 1 on the left, 1 on the right. So here we can see that in this equation, the only atom which is not balanced is hydrogen. This side we have 2 hydrogen, this side we have 3 hydrogen. So what am I going to do is, I'm going to make both sides equal by using a stoichiometric coefficient. So the easiest way to do that is, this side is 2h and this side is 3h, right? So I'm going to make this as 1 by 2h2. 1 by 2h2 is equivalent to 1h. So that makes it 1h plus 1h, 2h. So the equation is now balanced. But the problem is, I told you, you should not have fractions in the final equation. So how do I get rid of the fraction? I will multiply here with 2 so that it will become 2Na, 2H2O, 2NaOH, and 2 by 2H2 is 1H2. So our correct equation will be 2Na solid plus 2H2O liquid giving 2NaOH aqueous plus H2 gas. It seems option B is having the right choice. 2Na solid plus 2H2O liquid gives 2NaOH aqueous plus H2 gas. So this is how you figure out the correct balanced chemical equation from the word equation given. So I believe everyone understood the steps that we did and how did we balance the equation. Okay, let's move on to the next question. C6H12O6 plus 6O2 gives 6CO2 plus 6H2O. The above reaction is an example of. See, you can see that this is C6H12O6, which is basically glucose. And it is combining with oxygen to form carbon dioxide and water. If you recollect the information from the biology chapter, Life Processes, where you learned respiration in plants, isn't this equation same as respiration? This is the equation that you learned for aerobic respiration, isn't it? Glucose is combining with oxygen to form carbon dioxide and water. And you know that living organisms does aerobic respiration for one purpose. What is that? When you break down a mole of glucose, you are going to get energy. So if any reaction is accompanied by release of energy, that reaction comes under the category called as exothermic reaction. Correct? Exothermic reaction. Because if any reaction is accompanied by the formation of or by the release of energy at the end of the reaction, such reactions are called as exothermic reaction. So this is a perfect example of exothermic reaction. So it is not a displacement, it is not an endothermic reaction, it is not a neutralization reaction. It is an exothermic reaction. You guys know that exothermic reactions always releases great amount of energy. Now, if you look into the other options, displacement reaction. Displacement reaction takes place when one element which is more reactive than the other displaces that particular element from its salt solution, right? We have seen an example a few slides back, right? Iron plus copper sulfate giving iron sulfate plus copper. Then we have endothermic reaction, which is essentially any chemical reaction which is accompanied by absorption of energy. If energy is absorbed during the process of a reaction, that's called as endothermic reaction. Then we have neutralization reaction, which is the reaction between an acid and a base, where the effect of an acid is nullified or cancelled out by a base. That is called as neutralization reaction. So in this question, we have glucose combining with oxygen to form carbon dioxide and water. So this is an example for exothermic reaction. Right. The next question. Which of the following statements is true about the reaction given below? MnO2 plus HCl gives MnCl2 plus H2O plus Cl2. See, this particular reaction has been asked a number of times in board exam. I would say it is one of the most repeatedly asked question from redox reactions. So, manganese dioxide combining with hydrochloric acid to form MnCl2, manganese chloride plus water plus Cl2. So if you observe this reaction, you will understand that MnO2 is becoming MnCl2. This process involves removal of oxygen. So we know that any process that involves removal of oxygen is called as reduction. So MnO2 turning into MnCl2 is a reduction reaction. So definitely the other substance or the other reactant has to undergo oxidation. So if you look into this process, HCl getting converted into Cl2, this is an example for oxidation reaction where HCl, hydrochloric acid, is oxidized to chlorine. So this reaction is an example of redox reaction, and you can see who is undergoing reduction and who is undergoing oxidation. Here, to double check, which is the species that turns into oxidized form and which is the species that turns into reduced form, we have one more method. So I'm going to mention that method here. You can listen. MnO2 plus HCl giving MnCl2 plus H2O plus Cl2. This is our equation. So here, if you assign the charges on each of the species, you can identify who is oxidized or reduced. For example, in MnO2, the charge of Mn is plus 4. Then oxygen is minus 2. In HCl, hydrogen is plus 1, chloride is minus 1. Then in MnCl2, Mn is plus 2 and chloride is minus 1. In H2O, hydrogen is plus 1, oxygen is minus 2. In chlorine molecule, the charge of chlorine atom is 0. So what I did is, I assigned the charges on each of these species. We have a concept of redox reaction being explained in terms of electron movements. Electron movements can also define oxidation and reduction. In terms of electron movement, oxidation is losing electrons. If any species is losing electrons, that species is said to undergo oxidation. Whereas a reduction is gaining of electrons. If any species is gaining electrons, that species is said to undergo reduction. So in that aspect also you can examine this question and understand what is oxidized and what is reduced. You can see MnO2 and MnCl2. In that, the atom which is changing its configuration is Mn. Mn is changing from plus 4 to plus 2. Plus 4 to plus 2 is a process where electrons are added. Electrons are gained. You know that when electron is added to a species which is positive, its positive charge will decrease. So since reduction is gaining of electrons, we can say this process is reduction. Now, if you look into the next species, HCl, and the corresponding chlorine, you can see that chloride is minus 1 and chlorine is 0. So in this process, minus 1 is becoming 0. This is possible only when losing of electrons takes place. And hence, we can say that HCl is getting oxidized into chlorine because it has lost electrons in the course. So that is another way to look at it and answer the question. So here we have the options. What will be the correct option? HCl is oxidized into chlorine. That option is correct. MnO2 is reduced to MnCl2. That option is also correct. And then we have also studied how to identify the oxidizing agent and reducing agent. A species which is undergoing reduction is called as the oxidizing agent. And a species which undergoes oxidation is called as a reducing agent. Correct? So, MnO2 is the oxidizing agent and HCl is the reducing agent. So here we can say in this other options, it is written that MnCl2 act as an oxidizing agent. That is very much wrong. And HCl act as a oxidizing agent. That is also not correct. So the correct options are 1 and 2 only. So the answer for our question is option C, which is 1 and 2. HCl is acting as a reducing agent here. It's not an oxidizing agent. So I believe this question is clear to everyone. And remember that this is one of the most frequently asked questions in boards. Let's move on to the next question. It is important to balance the chemical equations to satisfy the law of conservation of mass. Which of the following statements of the law is incorrect? So, the law of conservation of mass, I already gave you an introduction about that. Law of conservation of mass states that the mass of the reactants must be same as that of the products. So, let's read and understand these options. First option says the total mass of the elements present in the reactants is equal to the total mass of the elements present in the product. That is a correct statement. Our question is, which of the statement is incorrect? So, first statement is correct. Second statement, the number of atoms of each element remains the same before and after a chemical reaction. That is true. If you have some number of atoms of particular element on the left side, which is 3 or 4 or 5, that same number should be there on the right side of the equation also. So that option is also correct. The chemical composition of the reactants is the same before and after the reaction. That is completely wrong, because when a chemical change happens, the chemical composition changes. For example, H2 combining with O2 giving H2O. You can see that in this particular reaction, before the reaction, we have hydrogen gas and oxygen gas. But after the reaction, we are having H2O. So we can say that before the reaction, the chemical composition was hydrogen gas and oxygen gas. And after the reaction, now it is liquid water. So the composition has changed. So in every chemical reaction, the chemical composition is going to change. So this statement is not correct. And the last statement also we can read, mass can neither be created nor can it be destroyed in a chemical reaction. That is very much true. It is basically the statement of law of conservation of mass. Mass can neither be created nor be destroyed. It is just an interchange of the atoms in the chemical reaction. So the total mass remains constant. So option A, B and D are correct, but option C is incorrect. So the correct option for this question is, the answer for this question is option C. Let's move on to the next question. Which one of the following reactions is categorized as thermal decomposition reaction? See, when we talk about decomposition reactions, a reaction in which one reactant breaks down into two or more products, that is called as decomposition. And this decomposition can be triggered by heat, light, or electricity. If it takes place in presence of heat, you learn that it is called thermal decomposition. If it is by light, it's called photolytic decomposition. And if it is by electricity, it's called electrolytic decomposition, right? So you can see in this, the first reaction, 2H2O giving 2H2 plus O2. In this reaction, water is decomposing into hydrogen gas and oxygen gas, correct? And you have learned this reaction under electrolytic decomposition or electrolysis. We have to pass electricity through water so that water will decompose into hydrogen gas, which is released at the cathode, and oxygen gas, which is released at the anode, right? Now, second reaction is 2AgBr giving 2Ag plus Br2. This is silver bromide, a yellow colored salt. Silver bromide or silver halides are sensitive to light. So this particular decomposition is photolytic decomposition. Same is the case for the next one also, silver chloride, a white colored salt breaking down into silver and chlorine. This is also example for photolytic decomposition. Now look at the last option. It is limestone, calcium carbonate decomposing into quicklime and carbon dioxide, or calcium oxide and carbon dioxide. This is an example for thermal decomposition, because when we take limestone and start heating it, then it decomposes into calcium oxide and carbon dioxide. So this is an example for a thermal decomposition reaction. Now, one more important point to keep in mind when you learn decomposition is that all decomposition reactions require some form of energy to be supplied for it in order to make the reaction happen, right? So they belong to endothermic reactions. What is endothermic reaction? A reaction which is accompanied by absorption of energy. That energy can be in the form of heat, light, or even electrical energy. So for the question, our answer will be the last option. Calcium carbonate decomposing into calcium oxide and carbon dioxide is an example for thermal decomposition, right? So let's move on to the next question. Burning of natural gas is an endothermic process. See, you guys know that natural gas is methane, having the formula CH4. Burning in air means it is in combining with oxygen, and you know that all the hydrocarbons, they burn in air to form carbon dioxide, water, and a lot of energy is released. And because of this reason, since they release a lot of energy, we use them as fuels, correct? Compressed natural gas or methane is such a fuel. So the balanced equation is CH4 plus 2O2 giving CO2 plus 2H2O plus energy. So you can see that the assertion statement says burning of natural gas is an endothermic process. That is wrong, because when you burn natural gas, you are getting energy out, isn't it? So that reaction is accompanied by release of energy in the form of heat and light. So it is a category of reaction called as exothermic. It is not endothermic. So our assertion statement is wrong. Now the reason given is methane gas combines with oxygen to produce carbon dioxide and water. That is very much true, because from the reaction we can understand that methane is combining with oxygen to produce carbon dioxide gas and water. So the reason statement is correct, but the assertion statement is false. So our option will be A is false, but R is true. Is it clear to everyone? Okay, perfect. So let's move on to the next question. Give an example of a decomposition reaction and describe an activity to illustrate such a reaction by heating. See, there are a lot of decomposition reactions you learned in your textbook, right? So let's take any one example. Let's take lead nitrate. You know that lead nitrate is a white colored solid salt, right? So when you take lead nitrate and heat it, then it will decompose into lead oxide, which is also a solid having a yellow color, and nitrogen dioxide gas is produced, which is a brown colored gas. So this will be coming out of the test tube as brown fumes, plus it will release oxygen gas as well, right? And this equation we already saw in one of the balancing question. So the balance equation was 2PbNO3 twice gives 2PbO plus 4NO2 plus O2. This is the complete balanced equation of lead nitrate decomposition. And it is a perfect example of a decomposition. Specifically speaking, it is an example for what kind of decomposition? It is thermolysis. So you can quote any example of a decomposition reaction, whether it is electrolytic decomposition of water, or whether it is thermal decomposition of calcium carbonate, or thermal decomposition of ferrous sulfate, or photolytic decomposition of silver chloride, or photolytic decomposition of silver bromide. All those things can be written as an answer here, because they asked, give an example of a decomposition. So you can write any example in this category. Is it clear? So here, describe an activity to illustrate such a reaction by heating. So the activity you can briefly write as some amount of lead nitrate is taken in a test tube and it is heated. Then we will observe that brown fumes will be coming out of the test tubes, which is due to the release of nitrogen dioxide. And we have the yellow colored solid formation at the bottom of the test tube, because lead nitrate will decompose into lead oxide. And also you have oxygen gas being released. Being a colorless gas, we can't see oxygen, but we can bring a ignited splint near to the mouth of the tube, and this, the ignited splint will get reignited, or it will burn if it is oxygen gas. Like this, you can draft your answer as an activity there. Okay, so this is the way how you answer this particular question. Right. So when you learn this question, when you go through this question, I request you to write down all the decomposition reactions that you have learned in this particular chapter. Okay, I have already listed the names of all the decomposition in this question. So please go through it once so that you are confident about that area. Great. Let's move on to the next question. What is the color of ferrous sulfate crystals and how does this color change after heating? See, ferrous sulfate crystals, when they specifically mention that name, you are talking about ferrous sulfate heptahydrate, which is FeSO4.7H2O. And this is a pale green colored salt. And they asked, how does this color change after heating? So, when you heat ferrous sulfate, all the water which is present in the crystal will be evaporated. All the water will be evaporated, leaving only ferrous sulfate, which is colorless or it is having a white color. So we can say the change that you observe when you heat ferrous sulfate crystals is that the pale green color of the ferrous sulfate will change into white color due to the formation of anhydrous ferrous sulfate. That means ferrous sulfate without water of crystallization. That is called anhydrous ferrous sulfate. So that is the answer for the first part. Now, in the second part of the question, they ask, name the products formed on strongly heating ferrous sulfate crystals and what type of chemical reaction occurs in this change. So, if you strongly heat it, what will happen? The FeSO4 formed in the first step, when strongly heated, it will decompose into Fe2O3 plus SO2 plus SO3. So, the balance equation is 2FeSO4 breaking down into Fe2O3 plus SO2 plus SO3. So, it is an example for a thermal decomposition because we are heating it and making the decomposition happen. So, it is an example for thermal decomposition. Is it clear? Is it clear? Right. So, in this, I want to add few more observations. One is, ferrous sulfate anhydrous is having a white color and it changes into brown colored Fe2O3 and it also results in the formation of two gases here. What are the gases? Sulfur dioxide and sulfur trioxide. You know that these two gases are the oxides of the non-metal called sulfur and these are acidic gases. That means if you bring a wet blue litmus paper near to the mouth of the test tube, it will turn into red because SO2 and SO3, they are acidic gases and they have a burning sulfur-like smell. So these are the observations that we see during this reaction and it belongs to thermal decomposition reaction category. Clear, right? Great. So let's move on to the next question. What happens when an aqueous solution of sodium sulfate reacts with an aqueous solution of barium chloride? You see, again, I told you the importance of that double displacement reaction. It is again coming, as a frequently asked question here. What happens when an aqueous solution of sodium sulfate reacts with aqueous solution of barium chloride? So we already wrote the reaction. Sodium sulfate was Na2SO4 aqueous solution reacting with barium chloride, which is BaCl2 aqueous, and you are getting sodium chloride aqueous plus barium sulfate solid because it is insoluble in water, so it will precipitate in the bottom of the test tube. So a white colored precipitate is formed when you mix barium chloride with sodium sulfate. Is it clear? State the physical conditions of the reactants in which the reaction between them will not take place. This is a very important question. You should see that in this reaction, what is the physical state of both the reactants? We know that sodium sulfate is a salt, correct? We have to dissolve this salt in water to make them as an aqueous solution. And even barium chloride is also a solid salt. We have to dissolve them in water to make it into an aqueous state. Only when you make them into these aqueous forms, then only they will react. So they are asking in this question, state the physical condition of reactants in which the reaction between them will not take place. That means if they are not in the aqueous state, but rather if they are in the solid state, we will never see a double displacement taking place between them. So that will be the answer for this part of the question. And also write the balanced chemical equation for the reaction and name the type of the reaction. So this reaction is a double displacement reaction, as well as we can also categorize this under one more category, which is a precipitation reaction, because at the end of the reaction we see that a solid precipitate of barium sulfate is formed. Clear? Right. Now let's move on to the next question. Decomposition reactions require energy either in the form of heat or light or electricity for breaking down the reactants. Write one equation each for decomposition reaction where energy is supplied in the form of heat, light and electricity. So plenty of examples we have already learned. So let's write one example for each category. So heat induced decomposition. We can say limestone. Limestone on heating will form quicklime plus carbon dioxide. This is an example for thermal decomposition, right? Calcium carbonate on heating will form calcium oxide plus carbon dioxide. Then similarly, with the light, when light falls on silver halides, we can quote that example, say for example, AgCl. AgCl is a white colored solid. So this white colored solid on heating, when exposure to light, so on top of the arrow we can write light, it will form Ag plus Cl2. Ag is in the solid state and chlorine is a gas which will escape. So the balanced equation is 2AgCl giving 2Ag plus Cl2. This is the photolytic decomposition or light induced decomposition. And then we have decomposition induced by electricity. When we pass electricity through water, we have learned that water will break down into hydrogen gas and oxygen gas, correct? So that example we can quote here for electrolytic decomposition. So liquid water, when electricity is passed through it, it will break down into hydrogen gas and oxygen gas. So the balanced equation is 2H2O giving 2H2 plus O2. So you can see that we have listed three different examples. One for heat-induced decomposition, one is light-induced decomposition, and the other one is electricity-induced decomposition. Is it clear? Right. Now let's move on to the next question. 2 grams of silver chloride is taken in a china dish, and the china dish is placed in sunlight for some time. What will be your observation in this case? And write the chemical reaction involved in the form of balanced chemical equation and identify the type of chemical reaction. As you can see, it's a 3 marks question. What you have to do is you have to specifically answer to the questions, right? So first thing is, the question is, what will be your observation in this case? So we know that silver chloride is AgCl. AgCl solid, when taken in a china dish and you expose it to sunlight, it will break down into Ag and Cl2, correct? Cl2 is a gas which will escape and Ag is a solid which will be seen remaining in the china dish, right? So 2AgCl giving 2Ag plus Cl2. So part by part if you answer, first part is, what is the observation? What is the observation? Observation is the white AgCl decomposes to form grayish silvery metal, right? That is the observation. And second thing, write the chemical reaction involved in the form of a balanced chemical equation, which we already did. This is the balanced equation. And identify the type of the chemical reaction. So here we can say it is an example for photolytic decomposition or photolysis. Photolytic decomposition. So that is all about the silver chloride decomposition. And you know that one of the most important application of this decomposition is that this was used in old school photography, right? Where the film-based photographic techniques were there at that time. We use silver chloride as the coating for the film. Right. Hope it is clear. Let's move on to the next question. Identify the type of reaction taking place in each of the following cases and write the balanced chemical equation for the reaction. Okay, so first thing, zinc reacts with silver nitrate to produce zinc nitrate and silver. So zinc reacts with silver nitrate AgNO3. It will give definitely zinc nitrate and Ag. This is an example for a single displacement reaction, correct? It is an example for a single displacement reaction. So in order to balance this equation, let me put 2AgNO3 and 2Ag. Because this side I have 2NO3, so I multiplied here with 2 and 2Ag is here, so 2Ag is here. So it is a balanced equation now. Clear? Now the second question is, potassium iodide reacts with lead nitrate to produce potassium nitrate and lead iodide. See, potassium iodide, which is Ki, react with lead nitrate. Lead nitrate is PbNO3 twice. So what will happen here? We are mixing two salt solutions, right? Aqueous potassium iodide mixed with aqueous lead nitrate. So what will happen? We learned that there will be a double displacement reaction happening, and the result is we get potassium nitrate plus lead iodide. Lead iodide is insoluble in water, so it will precipitate, and you know that it is a yellow colored precipitate. So these are the two reactions asked in that question. So the first category of the reaction is an example for single displacement reaction, right? And the second one is an example for double displacement reaction. So hope it is clear to everyone. Right. So let's move on to the next question. Yes, see, another repeatedly asked question. I think I already mentioned about this to you, that this specific example of redox reaction is asked many times in board exam. So this is something you should not forget ever. In the redox reaction, MnO2 plus HCl gives MnCl2 plus H2O plus Cl2. Look, we have already identified that MnO2 is becoming MnCl2, and that is removal of oxygen, so it is reduction, right? And HCl is turning into chlorine, which is oxidation. So with reference to that, let's read all the options. First option says MnO2 is reduced to MnCl2. That is correct. HCl is oxidized to H2O. That is wrong. HCl is not getting oxidized to H2O. Rather, HCl is getting oxidized to chlorine, correct? So MnO2 is oxidized, MnO2 is reduced to MnCl2, that is correct. HCl is oxidized to chlorine, that is also correct. So our correct option should be option B, right? We can also read on the other options as well. MnO2 is oxidized to MnCl2, that is wrong. HCl is reduced to Cl2, that is also wrong. MnO2 is oxidized to MnCl2, wrong, and HCl is reduced to H2O, wrong. So you should have a clarity on describing what is oxidized and what is reduced. Is it clear? So MnO2 is what is reduced to MnCl2, and HCl is oxidized to Cl2. And also I told you how to identify the reducing agent and the oxidizing agent. Okay? Never forget this. It's a very important example. Okay, let's move on to the next question. Identify the type of the reaction mentioned above in 1 and 2. Give one example for each type in the form of a balanced equation. Okay, that's really a good question. Look at this. It's a hypothetical reaction that they are giving, and you are asked to identify each category of the reaction. Okay, guys, look. A plus BC gives AC plus B. So, an element is reacting with a compound, and you get a compound plus an element. So, when you observe this, we understand that A is displacing B from BC and taking its place, correct? So what did we learn about this kind of reaction? This is single displacement reaction. Single displacement reaction. And they are asking us to write one example also. So we can write the classical example, zinc plus copper sulfate. When you dip a piece of zinc in copper sulfate solution, what will happen? You will get zinc sulfate plus copper. So this is a single displacement reaction. Okay. Now look at the second question. AB plus CD gives AC plus BD. Yes, without any confusion, you can say the answer of this, right? AB plus CD giving AC plus BD. What is happening here? AC plus BD, they are mutually exchanging, correct? Mutually exchanging. So if a mutual exchange happens between two compounds, that belongs to which category? It is double displacement reaction. It is double displacement reaction. Let's write an example. We learned one example just before, which is PbNO3 twice, lead nitrate plus potassium iodide gives PbI2 plus potassium nitrate. This is an example for a double displacement reaction.